10:30. We'll go ahead and get started. I'd like to go ahead and thank everybody for coming today and joining us for this mini career chat. We're going to be focusing on engineering today. I'll go ahead and introduce our two alum speakers, and we may have one more that will pop in, but for now we've got Greg and Jake. Jake Sparks graduated in 2005. He is an engineering manager for, I could say this wrong, Cryomagnetics. And Jake, okay, did I say that right? Okay, cool. And then we've got Greg Dudgeon. I'm not sure if I said it correct. Okay, cool. He graduated in '89, and he's a system integration and test engineering manager at Lockheed Martin Corporation. So I will go ahead and hand it over to whoever would like to take this off and start speaking first.
I guess I'll start off. So just a quick summary of how I got to where I am right now. I double majored in math and physics when I was at Center College. Although back then they'd only let you choose one or the other, so I chose physics. My intention was to get my PhD in physics down at Texas A&M University and then work at the superconducting super collider, which was going to be built there at the time. That got canceled. I ended up working at Fermilab up in the suburbs of Chicago. Got my master's in physics and kind of fell into test engineering because there's always a need for someone who understands how the equipment is working and how to test it. I worked for a while in fiber optics when that was booming. Spent a couple of years working for Hewlett Packard out in Northern California, just north of San Francisco. Then I was back in New England, worked about 14 years chasing startup gold. Got close once or twice, but after all those startups ended up failing, I went back to big companies, and I've been working in defense industry for about 6 years now. That's my background. Test engineering in general, talk about that. There's really no specific degree for test engineering. We've been doing at Lockheed and then before at BAE, which was where I was before Lockheed. Over the past few years, we've been steadily hiring engineers who have a degree in computer engineering or mechanical engineering or electrical engineering. But what I'm looking for as a hiring manager is someone who has a good background or at least some knowledge of electrical and software and mechanical. I want someone who can at least look at a electrical schematic and know kind of what the heck they're seeing. I want someone who can do some basic programming, and I want someone who has at least some level of mechanical aptitude. Because at the end of the day, the major things that a test engineer has to do is you develop and maintain and upgrade test stands. And that includes the hardware components and the software components. So you are buying pieces of test equipment that can run anywhere from, a couple of grand up to a couple of $100,000. You're putting them in a big rack typically, unless it's just sitting on a desk somewhere. And you're writing software to automate that system and, automate the front end GUI for the technician who's going to eventually run it and save that data, right? But also, in a lot of cases, a test engineer will also be expected to know what the data is saying, to be able to understand it and draw conclusions from it. So having a good background in statistics is important as well. You need to know at least the basics of SPC, statistical process control. Knowing what Six Sigma is all about is helpful as well. If not, we'll train you. But that's basically what test engineering is. If you were wanting to pursue that, I've got a few more minutes. If you're wanting to pursue test engineering, I would say, first of all, learn LabVIEW and maybe test stand as well. LabVIEW is a major tool, has been for a couple of decades now in test engineering and actually on the manufacturing floor as well. It's a graphical programming language. I have been at some companies in the past that have used, well, Visual Basic when that was big in the 90s, and then VB.net. A few companies will write code in C++. Some newer ones will use Python, but LabVIEW is still the 600-pound gorilla. I already said understanding of statistics, knowing how to analyze data. If you want to know what kind of software tools, look at getting familiar with either JMP or Minitab. Those are both very powerful statistical analysis programs, basically Excel on steroids. You should also know how to use a DMM, an oscilloscope, and a logic analyzer, or at least know what they are. Get a solid background in software and electrical engineering. What else? Know your way around the basics of a 3D modeling program is helpful as well. Either Pro-E, although I think that's Creo nowadays, or SolidWorks. I've been at companies that have used both of them. But other than that, that's about my 5-minute elevator pitch for test engineering. Jake?
Yeah. So definitely noticed some parallels to my path there when Greg was talking. I graduated in 2005. Came to Center, having a general sense of kind of what I thought engineering was, but wasn't quite certain that was the path I wanted to go, and thought that the dual degree engineering program they were offering at the time was a good path for me. So similar to Greg, my degree from Center is in physics with a minor in math. And then after Center, I went to Washington University in St. Louis for 2 years there to complete a bachelor's in mechanical engineering. While I was in St. Louis, I had a summer internship with an aerospace company there, GKN Aerospace, which exposed me a lot to the, I kind of ended up there in the more of the manufacturing side of things, what most places will call a manufacturing engineer or a production engineer. I've always been a pretty hands-on kind of person, and really found that side of things to be very interesting. So I ended up getting into that right out of college. Excuse me. Began working for a company called Denso, which is a major supplier to the automotive industry. They have a large facility down here in Tennessee where they make a number of different automotive components. Plant I was in manufactured starters and alternators. And again, as a production engineer, my responsibility was basically, developing. I used to explain it to people as, I don't design the product, I design how it is made. I would design the processes that we would use to produce parts most efficiently, decide what type of equipment was needed for that, head up procurement of those things, specify and procure those things, and then working with process improvements. Some of the statistical techniques that Greg alluded to are huge in a high volume environment like automotive. Some of the products that I was responsible for, we were targeting producing 30 to 35,000 of the same part a day. So obviously you can't individually inspect every single one of those. So you look at things from a statistical perspective to how you can maintain and improve quality there. I was at Denso for about 8 years, and then after that came to my current position at Cryomagnetics, which is pretty much night and day from Denso. We are a small custom manufacturer of. Sorry, I thought.
Sorry, Jake, if you can hear us, it looks like you're going in and out.
Sorry, I froze for a second. Associated cryogenic and flyer. We have it now.
I think we can hear you, but your screen's still frozen. Maybe we can still hear you, I'm not sure. Okay, I think he's frozen. Maybe Jake, you can try going out and then coming back in. Greg, would you like to say anything else while we're waiting on Jake? Oh, I think we got Jake back.
Yep.
Cool. Maybe.
I might. I'll try to turn my video off. Maybe I've got a bandwidth issue here.
That's fine. Yeah.
Okay, so everybody still hear me? Okay. Yeah. Okay. So yeah, like I said, we are a custom manufacturer of superconducting magnets and the associated cryogenic and vacuum equipment that is needed to operate those. Don't know when it got cut off, but I was saying our customer base is primarily in the academic field, university labs, researchers that are doing materials characterization sorts of research. But these sorts of systems are also used in several medical applications. We've worked with a couple of companies who are doing proton therapy systems, which kind of is similar.
Jake, I think your audio is now going in and out.
Particle accelerators. Well, is that any better?
Yeah, that's a little better. Yeah.
Apologies for that. It's giving me a notice that's saying my internet connection is unstable.
I'm so sorry.
Not quite sure what's going on there.
No problem.
But yeah, we're so like I said, kind of night and day from where I was before it did. So we're a smaller company, about 60 or 70 employees. My team that I'm the engineering manager of, where we have a couple of people who focus more on mechanical design, and then a couple of people who focus more on the magnetics of what we produce. So the mechanical guys are kind of have more of a mechanical engineering background. Looking at the magnetic side of things, we have folks that have backgrounds in physics and mathematics. More directly. Basically with my background, I was brought in here to look more at our manufacturing side. As we've scaled up pretty significantly over the last 5 years, still nothing approaching the kinds of high volumes you would see in automotive or what have you, but trying to bring some of those philosophies here, in terms of standardizing our processes, looking at ways that our product can be produced more efficiently. One of the things I've spent the morning doing as an example, I'm looking at designs in terms of design for manufacturing, looking at it in CAD to thinking about how it's going to be produced in the real world, which is obviously always a critical component there. So, but like I said, I've been here. I'll be 6 years in January. So. So I'm trying to.
Well, thanks.
Yeah.
Thanks, Jake. I wasn't sure if we lost you again or if you're done.
I trailed off there a bit. I apologize.
Yeah. Well, thanks. Thanks, Greg and Jake. So we have some time left. Students, do you all have any questions for Greg or Jake? This would be the best time to ask them. You've got them right here with you. So don't be shy.
All right, so as someone with a math background, would you recommend going to grad school before trying to get involved in these labs?
Before getting involved in engineering, or?
Yes, I meant like getting like a post-grad degree in engineering before trying to go down that track.
Either that, or at least maybe try to do a co-op as an engineer somewhere to show that you had some, real world experience in that. If I were to hire someone with a math degree, fresh out of college, I would look at if they had taken classes in real world applications. I would look if they had more than just the basic 1 or 2 classes in statistics. I would look at whether they had done some programming, any kind of numerical analysis related programming as part of their math degree.
Yeah, I think to Greg's point, I think a lot of that, excuse me, depends on a point that I think I forgot there in the confusion, but that I wanted to try to make as well is that engineering is an extremely broad field. Even with the the typically defined majors, mechanical engineering can mean everything from designing HVAC systems and piping systems to designing cryogenics like we do here. So, the example I was going to give, one of our magnet engineers did not have any sort of educational background in engineering, but he does have a PhD in mathematics. So he has had to learn a ton about the physical design of these things on the fly, here on the job. But
yeah,
background in the mathematical technique.
To Jake's point, the part of Lockheed Martin that I am in right now, without going into too many technical details because some of it's classified, but we are dealing with microwave technology. And there's on the theoretical side of it, well, not theory, but on the more hardware side of it, there's a lot of math-heavy things involved with differential equations and a lot of electromagnetic theory. So with a math degree, if you showed that you had some, classwork or training in real world applications like that, and showed some facility with being able to apply that, that would help.
Sure. And can I ask a follow-up? Do people you work with almost entirely have postgraduate degrees?
No. I would say that, and I've only been here at Lockheed Martin for about 7 or 8 months. Before that, I was at BAE, which I don't know if you've heard of them or not. They're another big defense industry conglomerate, but I was with them for close to 6 years, and most of the people in management did have an advanced degree of one form or another. But a lot of the engineers didn't. And if you are working for a bigger company, a lot of the times they will pay for you to work on a post-grad degree part-time.
Yeah, I've had a very similar experience to Greg there when I, at Denso, a much larger company. I almost none of our primary engineering staff had advanced degrees, but I knew some of the upper management did. But again, I will say that there's a cultural element there as well. With it being a Japanese company, they're very big on developing people internally, kind of bring people in at a basic level and develop them internally. Here where I work now, excuse me, a couple of our engineers have master's degrees. One has a PhD, but a couple of our primary cryogenic designers just have a bachelor's degree. So yeah, really all depends.
You go ahead.
Oh, I was going to toss out a suggestion. I do remember my senior year, I had designed two customized classes. One that was just independent study with me and a physics professor, and the other one was a customized math class with me and another guy. Which was boundary value problems and specific applications of them. But the physics class was on, I think, crystal studies or something. But I would suggest if you wanted to try to tailor something like that specifically to what you might be looking for, that would be useful. For example, if I were in your shoes right now, looking to get into test engineering, I would talk to one of your professors about maybe designing a class specifically on using LabVIEW to do something, some kind of specific test, or an automation of something in a chemistry lab, for example, or something like that. That might be worthwhile. You could learn something about data acquisition between computers and test instruments and things.
Back in, see if he has any other last minute thoughts. Jake, can you hear us?
Yes, I can. I apologize for the continuous. I never.
No problem. It is the life we're living in now, living in this virtual world. Jake, do you have any last minute remarks that you would like to make?
Nothing I can think of in particular. Like I said, just to kind of reiterate that, if engineering is something you're interested in, it's a very broad field with tons of niches, and if there's something in particular you're interested in, and I guarantee you there are academic programs and companies out there doing it. It's a matter of finding that right fit, and finding that right fit. So,
any last minute questions from students before we close out today? All right. Well, I want to thank everybody for coming. Greg, Jake, I really appreciate it.
Thank you. Enjoyed it.
Yeah, great.
Yeah, same here.
Great. Well, if anybody needs to contact you, would they be able to do that for the CCPD? Is that something you guys would be open to?
Sure, that's fine.
Okay, great. So students, if you have any questions, feel free to contact the CCPD and we'll put you in touch with Greg and Jake. All right. Well, I hope everybody has a wonderful day today, and happy holidays. Thank you so much.
Thank you.